Our Sun wasn't always thought to be the centre of the solar system. The ancient Greeks and those that came before them believed that the Earth was the centre of the universe, the geocentric model, and everything else, including the Sun and other stars, orbited around it. It wasn't until good quality telescopes were invented, and after painstaking observations by astronomers such as Copernicus, Galileo and Kepler, that the heliocentric or sun-centric model became commonly accepted.
Stars are formed over millions of years as clouds of hydrogen collapse under their own gravity. Eventually, the gravitational pull becomes strong enough to cause hydrogen to fuse into helium, releasing huge amounts of energy in the process. The majority of stars began to form about 5 billion years ago, but the lifetimes of stars vary enormously depending on their size, and stars are constantly dying and being born over time. The most massive stars live for only a few million years, whereas the smaller stars, like our own Sun, can live for billions of years. It's estimated that our Sun has another 5 billion years before it begins to swell into a red giant, swallowing Mercury, Venus, Earth and Mars in the process.
When a star is born from a cloud of hydrogen gas, it quickly moves on to the main sequence where most stars spend most of their lives. The vast majority of the stars in the Milky Way, our Sun for example, are on the main sequence. As a star begins to run out of hydrogen fuel, it swells and cools, forming a red giant star. Red giant stars are, as their name suggests, red and very large. The colour of a star depends on its temperature, ranging from cool red stars through mid-temperature yellow stars like our Sun, through to extremely hot white and blue stars. The hotter a star is, the more power it will radiate, and this luminosity depends on the fourth power of the temperature. If you double the temperature of a star whilst keeping its size the same, the luminosity will increase by a factor of 16. If you triple the temperature, the luminosity increases by a factor of 81. Changing the surface area of a star has a more conventional effect. If you double the size of a star, then its luminosity will also double.
Stars come in many different types and are classified in many different ways. White dwarfs are small, high-temperature stars, whilst red giants are large, low-temperature stars. The brightest known stars are blue supergiants and hypergiants, whilst the largest stars are red hypergiants. The largest known star is VV Cephei, which has about 18 times the mass of our Sun, but is a billion times larger in volume and hundreds of thousands of times more luminous.
Scientists must rely on the light emitted by a star to investigate the star's properties. We can't hope to send a space probe to even our nearest star, Proxima Centauri, 4.2 light-years away. Stars emit electromagnetic radiation right across the spectrum: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. How much of which type of radiation is emitted varies depending on the temperature of the star. Cooler stars peak in the infrared and red visible parts of the spectrum, whilst hotter stars peak in the blue to violet visible and ultraviolet parts. Extremely hot regions of space, such as materials spiralling into a black hole, emit X-rays, making X-ray astronomy a very important tool for those wishing to investigate these objects.